But now we've become experts on ocean acidification because we now have the functional form of the concentration of H plus in ocean water, and we know that that's equal to the third root of the product of the first dissociation constant squared times the second dissociation constant times the pressure of CO2 squared divided by 2 times Henry's law constant squared times the solubility product equilibrium between calcium carbonate and the calcium cation in solution. So now we can go through and we can put each one of those variables in. We can put K1, we can put K2, and now let's explore something very interesting. Let's suppose that the pressure of CO2 has risen to 950 ppm, and that is the concentration of CO2 in the atmosphere that we are rapidly progressing toward, and that's an estimate of what the CO2 concentration in the atmosphere will be like at the end of the century. Now, today the CO2 concentration is just about 400 ppm, and when we do the calculation of the pH in today's ocean, pH today is equal to just about 8.2. So now let's increase CO2 from 400 ppm to 950 ppm. That's what we're going to do. So we're going to put in 950 times 10 to the minus 6 atmospheres. That's 950 parts per million. So then we have 2 times the square of the Henry's law constant times the solubility product, the equilibrium for calcium carbonate going to the calcium cation. So when we solve for this, we have that the H plus concentration is equal to 8.8 times 10 to the minus 9 molar. Aha, so this allows us then to calculate pH immediately because it's minus log to the base 10 of the H plus concentration, and that turns out to give us a value of 8.0 for the pH. So you look at that and you say, well, we've only dropped the pH from 8.2 to 8.0, but it turns out that that's a large increase in the actual concentration of H plus because we've been taking the logarithm to determine the pH. So this is actually a very large change in ocean pH. And this affects coral reefs. This is a case where we have about 375 parts per million of CO2, and the coral reef is very healthy. It has fish. Coral is, of course, an organism that actually lives and grows. When we increase the CO2 concentration to somewhere between 450 and 500 parts per million, then the reef begins to die. The acidity affects both the fish and the coral itself. And coral is also very sensitive to temperature. So we've increased the temperature by 1 Celsius over the original condition. Now, when we go to concentrations approaching 900 parts per million, and we increase the temperature by 3 degrees over the initial condition, now the reef has largely died. And we see this in the Great Coral Reef off of Australia already. The combination of warming temperatures resulting from the trapping of infrared radiation by CO2 in combination with the acidity that's going into the ocean through this carbonic acid reaction is extremely detrimental to these delicate organisms that live within the ocean.